Well, I certainly hope you've been enjoying our videos dealing with lists in Python, and we're going to wrap up. I know, you're upset about this. We're going to wrap up lists for right now by taking a look at using a list to build a matrix. Ooh, that's right. What are we talking about? We're talking about a grid. Think like a chessboard. Now, before we get into this, I need to remind you of something. Let's jump down to the Python shell and let me remind you of something. A list can be a container for absolutely anything, including another list. So look at this. We have a list inside of a list here. It's 10, 20, 30 in that list. And of course, I can have another list in this list. How about 40, 50, 60? And of course, I could keep going. Sure, so a list can contain other lists. Now, how do we reference the specific value out of a list? Well, we're still going to use an index. Sure, so you can play with this. You can print my list and you can play with the index. For example, I think 0, 0 for the index would be this list here. That's the first 0 index. And then I think 10 would have this second 0 index. So I think this is going to give us 10. And that's exactly what it does. So how would we get, let's say, the value of 50? No problem. This is index number 1, and inside there is the index number 1 as well. Yeah, 0 is here, 1 is here. So I think if we do this print over again, and we change this to 1 and 1, I think we're going to get the value of 50 returned. Yay! That's how easy it is to use these multiple index designations to locate right where you are in your list structure. Okay, so now that we've got this, let's think about the overall point of this video, and that is to be able to construct a matrix in Python. Well, that's going to be none other than a list of lists. Sure, think about it. We have this top row here of the chessboard, row 8, and we can think of row 8 as our list and then a list below it. Yeah, row 7. In fact, when chess folks are talking about their moves, they have a letter and number system like you see here. So notice they are using 2 index values to describe their moves. Sure, they're saying the pawn will move from A2 to A3. Or I think they just say the pawn moves to A3. Yeah, because it has to be that pawn that makes that move. By the way, I'm no chess master. I don't even play chess. I think I played chess like 3 times in my life or something. So anyways, but isn't this neat? Yeah, they're using 2 index values to describe that location. And notice we end up doing the same thing in Python. Okay, you want to see how easy it is in Python to create a chessboard matrix? Oh my gosh, incredibly easy. Let's pull that up. Let's get back to our idle shell here and let me open my chessboard Python and look at how easy the chessboard is to create. 1 line of code. And that's because of our list comprehension feature. And notice I'm having a little fun. I'm nesting 1 for in another for loop. That is how we can create the whole chessboard in 1 line of code. What I do notice is I create a row with this line of code right here, and each cell, if you will, in the row has nothing, just an empty space in it. So here is an empty row, and then it's nested inside another for loop that creates 8 of those rows. How clever. Yeah, so a loop in the list comprehension to very quickly create our matrix of 8 rows, all filled, of course, with the blanks. And of course, I print that, and then obviously you would, if we were programming a chessboard, we'd need to like put the right pieces in their places. So how about those rooks, those castles that are in the corners? Yeah, the corners of our matrix would be 0, 0, 0, 7, 7, 0, and 7, 7. Yeah, those would be those corner pieces. Now, when you run something like this, it looks awfully ugly, but if you look close, it works. It's just not aligned, right? It's not aligned. But look at this. Here is, I've just highlighted it. Here is the chessboard with all the blanks. Yeah, it's 8 rows of blanks that we constructed. Sure. And then look at this. Here it is with the rook in the rooks, I should say, in their appropriate positions. And isn't it neat? Even not properly lined up, even not with formatting on this, you can really see that these are correct. There's the top corner rook, there's the other top corner rook, and then here's the bottom left rook, and here's the bottom right rook of a matrix inside of Python. And again, it really is worth looking at one more time just how simple it was to create that matrix thanks to list comprehensions and a little nesting of our loops. So lists, oh my goodness, they're incredibly flexible and powerful, as we've seen in a whole bunch of videos dealing with these lists. Well, not as complicated, but certainly important are tuples. And I hope you'll be joining me for that video coming up next.